Hey guys, Mr. Black here, and today we're going to be talking about Coulomb's law. Okay, but before we get started talking about Coulomb's law, it's important that we talk about electric charge. Okay, so let's get started. So all ordinary matter contains both positive and negative charges. You do not usually notice the charge because most matter contains the exact same number of positive and negative charges. We call this the electrically neutral when it has an equal amount of both types of charges. Okay, so when an object has equal amount of both types, we call it electrically neutral. Okay, we've got an example here: positive charge plus 8, negative charge minus 8. So our total is going to be 0, right? So that's an electrically neutral. So with electric charge, objects can lose or gain electric charges. The net charge is also sometimes called excess change because a charged object has an excess of either positive or negative charges. A tiny imbalance in either positive or negative charge on an object is the cause of static electricity. So when you reach towards that door handle, that metal door handle, and you get zapped, it's because there's an imbalance there, right? We've got more positive or negative charge than we need, and it's trying to balance itself out. Electric charge is the property of tiny particles and atoms. The unit of electric charges is the Coulomb. And we'll talk about Coulomb's law here in just a second. So it's represented with that C. The quantity of charge should always be identified with a positive or negative sign. Okay, you should always be identifying whether it's positive or negative. Electric forces can be created between all electric charges. Because there are two types of charge, positive and negative, the electric force between charges can attract or repel. So like charges repel and unlike charges attract. So if you have a positive and a negative, those are going to attract. But if you have two positives, those are going to bounce off of each other. Okay, Coulomb's law relates the force between two single charges separated by distance. Okay, F represents the force, K represents Coulomb's constant, R is the distance between the two objects. Q1 and Q2 are going to be your charges. Okay, so Q1 would be charge for object 1, Q2 would be the charge for object 2. So this is just another representation of that. R, obviously there's the distance. Charges are Q1 and Q2, constant is K, and F is force. So we should be noticing that this looks very similar to our equation that we use for gravitation. So for Coulomb's law, this equation is so similar to our gravitational law, and they act very similarly in that they both operate by the inverse square law, and they both have constants. They're differing in the constant G is very small and the constant K is very big, and they also differ in that gravity is always attractive and charges can attract or repel. One uses the product of the charges and the other uses the product of masses. So there's a couple differences there, but they're very, very similar. So we should be familiar with how to solve these types of problems. Okay. So the force between two charges gets stronger as the charges move closer together, and the force also gets stronger if the amount of charge becomes larger. So the closer they get together, the stronger that charge is going to be if they're opposite charges, and then the force is also going to get stronger if the amount of charge becomes larger. So if you get more charge, that force becomes stronger. The force between two charges is directed along the line connecting their centers. So they're always going to be lined up. They're always going to be in a straight line connecting their centers. And electric forces always occur in pairs. Okay, the force between charges is directly proportional to the magnitude or amount of each charge. So doubling one charge doubles the force. Doubling both charges quadruples the force. And we'll talk about that and how we can work that out using some math in our example problems in a little bit. Okay, the force between charge is inversely proportional to the square of the distance between them. So doubling the distance reduces the force by a factor of 4, decreasing the force to 1/4 of its original value. This relationship, we've done this before, is the inverse square law because force and distance follow an inverse square relationship. Okay. And that's pretty much it for this lesson. We're going to talk about this more in the practice problems. Ask your teachers if you have any questions. Otherwise, Mr. Black out.